So another server, other servers do have log files. So all of this stuff I've showed you so far is on the app server. Now the SNMP traps log, it occurs on other servers as well. But the NSXSLog is a place to look for some types of data. It records the SIP signaling and some limited processing logic information. Now, I already showed you VTR where you could see how the network server makes its routing decisions. But the network server has its own XS log as well. It's a lot less complex. So the key thing is it shows phone calls coming in to the invite and then the 302 going out. But it also shows the options ping monitoring of other devices. So the network server sends these ping messages off to other devices. So let's look at that. So here we see, this is an example from an NSXSLog, and I'm going to go back by one actually. So this is the beginning of it. So here we see the tracking ID in the NSXSLog. We see the incoming invite. And this is this long message here showing how that that call came inbound to the network server. It shows all the original signaling data and the way that the numbers were formatted. So it shows that this was an attempt to call 919-630-5918. Then the network server does the lookup and it returns the 302. And here it says that the two options are 216.128.133.230. That's the best option. And the second best choice is 216.128.193.36. That's returned here as a way to route this call. So at this point, we are expecting an ACK message, but then this invite transaction is done. You can also see device monitoring where the network server sends options ping. So this is an example in green here. Where the network server sends an options message outbound to some other device. In this case, it's sending an options message to 216.128.193.38. And then you can see here, there's a response that comes in into 200 OK. So the device replies with that 200 OK, so the network server knows that it's operational. But if no reply had been received, the network server would have marked the device as offline internally, and that would have been an indication of a problem, and that would have changed the way routing was done. So it would have, the network server could have recorded that. So this is kind of an optimization that's used to allow the network server to know whether to prioritize certain routes and certain media servers. Because there's no reason to be continuing to send the app server or send other devices to traffic, to direct their traffic to a device that's not responsive or not reachable on the network. So the network server, if you set it up to, by the way you configure your hosting and ease and your routing and ease and your resource and ease, it will do this polling where it sends out a SIP options message and then it waits for replies to come back. The media server also has some logs, the media server syslog. So the main one you want to look at is this msfe file. It stands for media server front end, and it's got the SIP messaging, and it also has some limited data on RTP performance. If you've got an older version, then this note may be useful because there's these other log files. Let's look at some examples from the media server msfe log file. So for example, there's RTP information. So remember the RTP, the media, audio and video that's going to and from the media server is set up for auto attendance, for voicemails, for conference calls, and it actually will record us some data on the quality of that. And so for example, it's showing here that the fraction lost here, it was 0.019, so 1.9%. Packet loss, this was 0.39% packet loss, so substantially smaller packet loss. The larger numbers for fraction loss and jitter suggest a worse quality RTP flow. So if there's some sort of audio quality problems, the network performance needs to be improved. Another thing that you can see in the media server log is the SIP signaling, of course, how it gets controlled. And we already looked at what that SIP signaling looks like when we walked through the voicemail and the other calls. But you can also see the caching. So the media server caches the files that it downloads from the app server. And so, for example, it determined here it was trying to play this ringback.pcmu.wave file, determined that the file was stale based on the timestamp. And it goes and checks to see, so it actually goes back to the app server to check to see if that file has been changed. And if it has not been changed, it doesn't have to download it again. It's basically check the validity of the cache. And so what we see here is it goes and it checks the server, the app server in this case. It determines that the file has not changed, and then it continues to use the entry from the cache. So that's worth noting that if you change a file on the app server, and if you, especially if you're modifying, for example, localized files, so the ringback sounds or the tones and greetings that are used for different languages, then those are the kind of files that have consistent file names like ringback-pcmu. And the media server can't tell by file name that this is the same, that this is a different file than it got before. It's got the same file name. Now, if you upload a voicemail greeting, then that actually gets a new file name, and the media server fetches the new file immediately to play it back. So a voicemail greeting, an auto-attended greeting, or any of the other uploadable greetings, those are handled differently. So this caching really is something you mostly become aware of when you're troubleshooting a change of a file that where the file name is not automatically generated by a number. So the XSP also has log files that are worth looking at. Here's an example from the Apache logs, or in particular the Tomcat logs that show how files are downloaded. So this is as of this is updated for release 22. The directory here changed in release 22. So the HTTP and HTTPS requests are actually logged, and so here we have requests for user applications, for ordinary user applications deployed to the XSP show up here. So we see, for example, if somebody's using the call center, we're going to see those access requests, those HTTP access requests logged here in the var BroadWorks logs Tomcat access log directory. And we're also going to see cases where things are uploaded. So this is a case where a VVX310 phone is uploading its call list. So they keep a log of all the calls and it can upload it. That way, if the phone reboots, your call history is retained. Here's a case where an attacker is looking for files. So they're trying to do get commands. And you see here they're doing a get. There's a 302 and then a 404. And these 404s are the HTTP response codes, meaning that the files are not present. And so this attacker is pretending to be a Polycom VVX400, but it's actually trying to download OB-high commands. So this is the kind of attack that goes on all the time on the internet today. And the main defense against this type of attack is client certificate authentication or some other type of strong authentication mechanism for your devices. In the XSP, we can also see the device management debug log. So those are under var BroadWorks logs, XSP DMS debug log. So this shows the activity of uploading and downloading device configuration files through device management. So when your device connects into the XSP to download a config file, all the activity related to going and fetching that config file is logged here in this DMS debug log.